All right. So this is Algebra 1, Learning Target 2 for the assignment that is assigned March 30th, due August 5th. So with Learning Target 2, we are graphing quadratic. So Learning Target 1 was talking about the properties of the parabola, the graph of the quadratic. Learning Target 2 is graphing them. So first, we're going to look at graphing y equals x squared. So in order to do this, just a really basic start to this, we can just make a table. X, y, -3, -2, -1, 0, 1, 2, 3 for our x's. And remember, you can always hit pause, write this down. If I'm going too fast, you can just pause it or rewind it. Make sure you are taking notes with this, right? You've got the document that you can look at, the PDF, but also write this stuff down as you go through because it'll help you learn. Okay, so what we do here is to find, these are our x numbers. To find the y number, we just take the x number, multiply it by itself, or just square it. So 0 times 0 is 0, 1 times 1 is 1, -1 times -1 is 1, 2 times 2 is 4, -2 times -2 is 4, 3 times 3 is 9, -3 times -3 is 9. So this 0, 1, 4, 9, this is going to be really important to remember that because every graph, if you remember this 0, 1, 4, 9, that goes along with the 1 away, 2 away, 3 away from 0, or from that vertex, which we'll talk about, that'll help make graphing a lot more efficient. So to sketch this graph, we just go 1, 2, 3, -1, -2, -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we have a point at 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, 3, 9, -3, 9. And we get basically that. It'll be a little bit more exact, but maybe do it on a graphing calculator or something if you have grid paper. But you'll notice we have our vertex, axis of symmetry right here at x equals 0, right? It's decreasing all the way up until x equals 0. It's increasing when x is greater than 0. And the x and the y-intercept are the same both at 0, 0 here. So our vertex is here at 0, 0. So notice the vertex is at 0, 0. And then if you go right or left 1 from the vertex, you go up 1. If you go right or left 2, you go up 4. If you go right or left 3, you go up 9. So that's going to be important. So now, if we're going to graph, for example, let's move on to problem 2. We're going to graph y equals x minus h squared plus k. If you remember back to when we talked about transformations with absolute value functions, we can always find the vertex of the absolute value, that point on the v, by looking at these two values. So here the vertex is going to be at h comma k. Basically, if I put 0 in for x here, scratch that. If I want to get 0 squared, right there I need number minus number, same number minus itself. That's why we're going to get h minus h right there for our vertex. Right, because the vertex is when the input, the thing getting squared, is 0. And it'd be 0 squared, which is 0 plus k. It's okay if that didn't make much sense. But basically, let's just say h is positive. The graph, what we would do is we would go right h, up k. If h was, if it's x minus h, then we go right h. If this was x plus h, x plus a number, we would go left. Because we have a plus k, we're assuming k is positive, we're going to go up. If this was a negative number, we'd go down. So this is our vertex at h comma k. And then from the vertex, I'm just going to go right 1, up 1, left 1, up 1. And then if I go right 2, I'm going to go up 4, left 2, up 4. If I go right 3, I'm going to go up 9 from the vertex. So that gives us a curve that looks like this. And when we do actual examples, this will make more sense. It'll be easier to see when we actually have numbers in there. So now if I throw a little y equals a times x minus h squared plus k. Oh, so what happens here is we have the vertex at h comma k, right? So that shifts it left or right. If this was a plus right here, it would be a negative number for our x, for our vertex. If this was a minus k, we would have a negative number for our y. Now what the a value does is this is a stretch slash shrink, and it could reflect. It reflects if a is negative. So basically what you do is you find your vertex at h comma k, and then if you go right 1 or left 1 from the vertex, here you're going to go up whatever the a value is. Whoop, up a. If I go right 2 from the vertex, I'm going to go up a times 4 times a, and same if I go left 2. So here, this graph will get stretched. If a is a big number, it'll get stretched. If a is a small number, like a half or a quarter or something like that, it'll get shrunk. If I were to go right or left 3, I would go up 9 times whatever that a number is. Okay, so it'll hopefully make more sense when we throw some actual numbers in there. That's just kind of what the transformations are doing, or what those a, h, and k, or how to graph these. In general, regular x squared, start at 0, 0 with your vertex, over 1 on each side, up 1, over 2, up 4, because 2 squared is 4, over 3, up 9. We get these nice points on there. If it's x minus h plus k, this tells you where your vertex is, and you basically do the exact same thing you did here, starting at the vertex, over 1, up 1, over 2, up 4, over 3, up 9. If you have an a out front, you get your vertex at the h comma k, but you go over 1, up 1 times a, over 2, 4 times a, over 3, 9 times a. It's still that 143, or sorry, 149. All right, so let's do some actual examples here. Erase, erase, erase. So these examples will help you with problems 5 through 8, I believe, on the homework assignment. Or, sorry, just the assignments. It's all homework because you're at home. But, okay. There we go. So, starting with problem 1. Problem 1, we are going to graph. Get a pen that's working a little bit better right now. And it's probably going to dry out a little bit as well. Let's see if I can dry this out a little better. Okay, hopefully that worked. We have y equals x minus 3 squared minus 4. So notice there's the a value here is just 1. We don't write a number because it's just 1. And we have this minus 3 and this minus 4. So the minus 3 is going to shift our vertex right 3. So it's always the opposite of what's going on here for our x number. So it's going to be a positive 3 and then a negative 4 for our vertex. Our graph is going to be opening up because it's positive, and it's just going to have that 1, 4, 9 from the vertex. So I'm going to graph right here. 1, 2, 3, negative 4. That's my y number. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I'm going to put my vertex on first. So the vertex is at 3, negative 4. So I go over to x equals 3, y equals negative 4. I put a point there and I label it 3 comma negative 4. That's my vertex. Now from here, if I remember this 1, 4, 9, I can just go right 1 from the vertex, up 1. Left 1 from the vertex, up 1. I can go, so that's x is 1, x is 2. I'm going to go right 2 from the vertex, and I'm going to go up 4. Left 2, up 4. And then I'm going to go right 3 from the vertex, and I'm going to go up 9. So from negative 4 plus 9, we get 5. So I'm going to go left 3, up 9, right 3, up 9. And now I can just connect those dots with a nice curve. And we've graphed our parabola. Notice I included 7 points. The vertex, 3 points to the right of the vertex, 3 points to the left of the vertex. Right? And notice it's symmetric. So once you have the points on the right, you can just fold them over or reflect them over the axis of symmetry. Right? So remember the axis of symmetry would be right here. Axis of symmetry, which in this case would be x equals 3. Okay. All right, let's move on to the next problem. So problem 2, we're going to graph y equals negative 2x squared plus 8. So here, you will notice it doesn't have like a plus or minus inside the parentheses. It's just an x squared. But it does have a plus 8. So it's kind of like negative 2 times x minus 0 squared plus 8. Right? Our vertex is going to have an x number of 0. So the vertex is at 0, 8 in this case. It's always good when you're graphing a parabola to find where the vertex is first. That's the most important part, or sorry, the most important point on a parabola. Because it's that center point, it's either the maximum or the minimums. It tells us like what everything reflects over. It's got the most information in there. So you find the vertex first. So we're going to go ahead and go from there. One, 2, 3. Negative 1, 2, 3. And 1, 2, 3, 4, 5, 6, 7, 8. Vertex is there at 0, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 10. So now from the vertex, I'm going to remember this 1, 4, 9. If I go 1 to the right, normally I would go up 1. But I look at my a value here. This a value, this number multiplied out front, what this is doing, it's a negative 2 that's multiplying. So the negative part reflects. So the graph is going to go down. And then the fact that the 2 is going to stretch. Or what it's going to do, it's going to multiply this 149 times 2. So I used to have 149. What I'm going to do is I'm just going to multiply each of those by negative 2. It's going to be negative 2, negative 8, negative 18. So we go times negative 2 times this a value. So the negative part makes it from going up to going down. Notice those are all negatives now from the vertex. And then the 2 stretches it. It doubles that distance from the vertex. So starting at 0, 8, we go to the right 1 or the left 1, and we're going to go down 2. So right 1, down 2, left 1, down 2. Now if I go right or left 2 from the vertex, I'm going to go down 8. So here I'm at 8. If I take away 8, I'm down at 0. And that's 2 away from the vertex. Now if I go 3 away from the vertex, I'm going to go down 18. I'm not going to go down to the number negative 18. I'm going to go 18 away from that 8. So 18 away from the 8, I go 8 and then 10 more to get 18. So when I'm 3 away from my vertex on the x, I have to be 18 away on my y. 3 away, 18 on my y. Now I have my points, my 7 points that I want, my vertex, 3 on the right, 3 on the left, and I just connect them as best as I can with a nice little curve. I kind of missed there. Woo, let's just make that a big point. And there it is, right? We see our vertex, we've got our axis of symmetry, which is just the x-axis, or sorry, the y-axis in this case, right? Increasing up until the vertex, decreasing. We've got our x-intercepts, our y-intercept. Cool. Let's do the last problem here. So here, problem 3, we have y equals 1/2 times x plus 4 squared and then minus 8. So here, looking at this, remember the first thing we want to do is find the vertex. To find the vertex, we look and we say, aha! We have both of those. And remember, the x number of the vertex is going to be the opposite of what's going on here on the x. In other words, if I want to make this 0 squared, I would need to go negative 4 plus 4 to get a 0 in there. If I put a negative 4 in for x, negative 4 plus 4 is 0. So, we're at negative 4, comma 8 for our vertex. Vertex. Oh, but it's a negative 8 because that's a minus, right? So negative 4 because it's x plus 4, and we do the opposite. Opposite. Whoop. And then this is the same. So opposite for your x number, your vertex, same for the y number of the vertex. So now what we do is we just sketch out our graph. So here we have (1, 2, 3, 4, 5, 6, 7, 8), negative 8. 1, 2, 3, 4, negative 4, 5, 6, 7, negative 8. So at negative 4, negative 8 is our vertex. And notice, in this case, we have, let's get yellow. Yellow, oh, looks the exact same as green. Let's get orange. Here, the a value is 1/2. So remember how we had this 149 for our original, where a was just 1, or it wasn't written as a number? So that takes the 149, multiply all of these by 1/2. So we get 1/2, 2, and 4.5, or 9/2. Right, and that tells us if we start at that vertex, if we go right or left 1, we're going to go up 1/2 this time. And it's going to be up because it's positive. If I go right or left 2, for that 4, instead of a 4, it's going to be now up 2. And if I go right or left 3, instead of going up 9, I'm going to go up 4.5. All right, so we're going to go ahead and do that. So I go right 1, I'm going to go up 1/2. Left 1, up 1/2. Sorry, it's kind of hard to see it. I don't have grid lines on this. If I go right 2, I'm going to go up 1, 2. If I go left 2, I go up 2. If I go right 3, I'm going to go up 1, 2, 3, 4.5. If I go left 3, I go up, well, 4.5. There we go. This should actually be a little bit further out there, but that gives us the general shape. We've got our 7 points, and we're good to go. All right, we've got our axis of symmetry, we've got our vertex, and that's it. So, kind of to summarize, whenever you have one of these problems, find the vertex first. The x number of the vertex is going to be the opposite of these numbers. If it's just an x squared, the x number of the vertex is 0. The y number of the vertex is just whatever number is on the outside. If you had something like this, like let's say it was y equals 2 times x plus 4 squared, the vertex on this one would just be negative 4 comma 0, because there's nothing added or subtracted. That y number, there's no number there, so it's just 0 for the y number. So once you find that vertex, opposite of this number, for the x, that number for your y. Once you have that, then what you do is from that vertex, you identify, is there an a value that's different than 1? If it's just 1, or if it's just parentheses squared something, then you go right or left 1, up 1, right or left 2 from the vertex, up 4, right or left 3 from the vertex, up 9. If it's an a value that's not 1, if it's basically you take this 149, as you go right or left 1, right or left 2, right or left 3 from the vertex, you take that and you just multiply it by that number. If it's a negative, it'll change these into negative numbers. So the 149 turned into negative 2, negative 8, negative 18. So from the vertex, we went down 2, down 8, down 18. Here with the 1/2, we went right or left 1, 2, or 3. We took that 149, multiplied it by 1/2, and we went up 1/2, up 2, up 4.5. So you should be able to do the next 6 problems Once again, comment, email, remind, or office hours if you have questions. Plenty of ways to get a hold of me. Yeah, enjoy. Happy assignment doing.